my okay. Okay, now let me share my screen.
Please.
Can you see my screen?
Yes, I can see.
Okay, good. Okay. Now let me open my Ubuntu. Today we are going to start about SnappyHexMesh. Okay.
Okay, buddy.
Okay, where is the class? So it is basically here. Slash. Okay, now let me remove all these things. No, first of all, we are going to see. Let me check the files here. Dynamic management, professional security, and once again here, and CD space, and everything a constant. Okay, this is our system, and this is where Snappy had. Yes, there is it. Okay. Now let me open and explain this for you.
Okay, buddy.
Okay, now can you see it?
Yes, I can see.
Okay, let me open this for you. Okay, in SnappyHexMesh, what we do? The thing which we do, we just import our meshes from any external software. Okay, after exporting them, we can save them in the file in the format of .stl. Okay, for example, you can see there is a name of file which is 1.stl. Okay, then there is another name 2.stl, then another name 3. We can also define boundary conditions here. Okay, the first one is a inner cylinder, the second one is an outer cylinder, the third one is the 4.stl, then the ASCII. Okay, then these all are the name of the files. We are just importing our file from any other software in this case, and then we will mesh that case. Okay, this is the first point. Okay, the first point is that you have
Okay,
insert geometry in your OpenFOAM. This was the first, and 1.stl is a geometry, 2.stl is also a geometry, 3.stl is also a geometry, and then 4.stl is also a geometry, and okay, these all are geometries. There are three forms of meshes in STL SnappyX. One is the castle mesh. Okay. Second is the snap mesh. It will automatically snap. This will generate automatically a mesh from your surface or in your surface. This will just snap your mesh to the surface, and this is the add layer. If you want to add layer, boundary layer to your geometry, it will add this thing. Okay, and let me just go to down to show you. These are the control of the Castle mesh. Let me just go from there. This is the Castle mesh controls. Okay, so what is its value? Its value is refinement parameter. If a local number of cell is maximum cells on any processor, switch from the refinement followed by balancing current wage to a wage by balancing refinement. These are by default values maximum local cells. So the total number of cells maximum will be 10,000 in your case. These are by default. If you want more maximum local cells, you can increase its value. And if you want less number of maximum local cells, then you can decrease this value. Okay.
Okay, Wally.
Are you listening to me? Hello. Are you there?
So,
Just
Wally, I hearing you. I hearing you.
okay. Okay. Now the next is the maximum global cells. The maximum number of global cells, or you can see here, is the overall cell limit. But you see, you can overall your geometry will have maximum global cell like this, and the refinement will be immediately stopped upon reaching this number. So refinement level might not complete. And note this is a number of cells before removing the part which is not visible from the key point. The final number of a cell might be actually less than, though if this is the total number of cells, your mesh always contain maximum global cells of 2000. Okay, so the surface refinement loop might spend a lot of iteration refining just like a few cells. This setting will cause the refinement to stop if minimum refinement are selected for refinement. Note, it will at least done one iteration unless we cannot. If you can increase, if you want to increase surface refinement, then you can increase the minimum refinement. The minimum in refinement is 0, and right here maximum refinement cell. It depends upon your mesh, how much your mesh need refinement in case of your surfaces. Okay. Same is the case with the allow a certain number of imbalance during refining, since balancing is a quite expensive. So express function is the perfect overall cells and process is equal to 0 and maximum load. So the maximum, this is totally generated with a high performance computing. If you have to load your overall cells or maximum load unbalanced onto your core. So this basically unbalanced all the load. Okay. And the next
Okay,
thing
Wally.
is, let me just go down from here. And cell between, this is the most important point. What is this? This means the number of a buffer layer between different levels. These are the number of buffer. For one means normal. Okay, so the buffer layer is 1. 2:1 refinement restriction. Larger means lower and refinement. So these are the refinement levels. And the L cell between levels is 2. So the total cell between them is 2. So this value is most important in case when you are using this in the very high mesh. So that might be depend upon your features. Okay. So what about the next? The explicit feature refinement specifies a level for any cell intersected by its edges. This is a feature as read from constant try. Now you have to import your geometry. When you import your geometry in the constant directory in the polymesh, then this thing will automatically come to how many you have to define the feature refinement here. For example, these are 4, 4, 4, 4. All things are 4. Then you have to define these things. Use surface feature extracting. When you just extract minimum and maximum angle, they will automatically come into your folder and it will read them in this form e.mesh. Okay. And the next, the surface based refinement. Okay. Specify 2 level for every 2 surface. The first is minimum level. So what does mean by this 4 and this 4? This 4 is the minimum level and this 4 is the maximum level. So the minimum and maximum, the maximum level will not be greater than the minimum level, and the minimum level will not be, yes, the minimum level will be not greater than maximum. We have already seen the minimum and maximum level of a surface get refinement about the minimum level. The second level is the maximum level. See that's the multiple intersections where the insertions make an angle of resolution greater than the maximum level. The angle is always greater than the resolving angle. So in that case, we can get exact mesh of highly structured mesh. Okay.
Okay, Wally.
Okay, let me just explain them. What are they? These are the refinement surface. You want the refinement surface, propeller stem 3, 4, 4, propeller stem 2, propeller stem 1, propeller outer slender, inner slender. These are basically properties of your snappy mesh and how you just want in refinement. In case of outer slender, you find refinement 0, 0. You propeller you, if you want the maximum refinement is 4/5, when the propeller stem is 4/4, And in this case propeller stem 4 by 4, in this case 4 by 4. So the resolve feature angle is the maximum sharp angle. At that angle you want to intersect your geometry in different things. Okay, this resolve feature angle plays an important role in the meshing while you are meshing, because different region comes where you can just simply mesh your body and then you want to rotate, and this feature plays an important role in that cases. What is the next one? That's the region wise refinement. If you want any region to refinement, then you can specify here. You can see specify the refinement level for any relation to a surface. One of the three mode distance levels means or distance per surface to the wanted refinement level, and the distance needed to specify in the descending order. So descending order means first one be in the first one will in a smaller side and the second will be in a greater side. This meaning a descending order. And inside level is the only level entry. It is used and all cells inside the surface get refinement up to the level, and the surface need to be closed for this possible, and outside but the same cells or mode. These are the mode inside, outside, and distance depend upon you what type of refinement you want in your regions. Okay, this is the mesh selection. What does mean this?
Okay.
What does mean by this location in a mesh? This is the point in which if you want the mesh inside a geometry, this point must be inside, and if you want your mesh outside of your body, then this is the point where mesh snaps or starts. For example, if you want to mesh the outside of your geometry, then this point must be out in your outside of your mesh, not inside your geometry. And if you want to create mesh inside your geometry, then this point must be inside, okay, not outside. What are the next? The next are the snap controls. These controls, what does mean by these controls? These means number of a patch of a smooth iteration before finding the corresponding. So the smooth will be come for the 3 patch, 3 iteration will be run automatic, and the tolerance is of 4 in this case. Relative distance for a point to be attracted by a surface feature point or edge. So the true distance is the factor time local maximum edge length. So the maximum tolerance is here and the minimum is 1. You can it depends upon your problem, how many refinement you want and how exact your mesh you want your mesh. So in that case, you will use tolerance in your cases. Okay. So what about the next? The next is the solver. So these are the solver, the number of displacement of relaxation iteration. And if you want to iterate your solution up to 300 times, you can iterate it, and your max mesh displacement will be after 300 time intervals. What about the end relaxator? And relaxator is a 5 maximum snapping relaxation iteration should be before upon reaching the correct mesh. Because if your mesh is going in a good direction and you want to relax it to 5, it depends upon you how relaxation you will leave. What about the feature snapping? In a feature snapping, the number of a feature edge snapping is the iteration and leave out together to display the features at exact, and a feature snapper is a 10. And detect geometric only feature by sampling in the surface is implicit true. Yes, there are 2 controls in the OpenFOAM that are implicit and explicit, and if you want a multi-region feature snap, then it must be true. You can easily just capture them and just start your mesh in this case. And the next and the final case is the add layer. These are the boundary layers where you just want to snaps. So the first one is the relative size to what is the relative size to? This means that the thickness parameter relative to disorder relative size, that must be true. And how many number of layers you want to add per information you can add here in this information layer, form layer, how many layers do you want? The expansion ratio factor for a layer of a mesh, you can see the expansion ratio for mesh is always 1. It depends upon you how many expansions you want and in which direction you want. And final, the thickness of the final layer is always 0.3, and the minimum thickness is 0.1. If you want to grow from this, and the grow is right now it's 0, and it depends upon you how much you grow. The feature angle is 30. You can read here. Then the surface is when not extrude the surface, if you don't want to extrude the feature angle, and the flat surface, when your surface is the flat, the angle must be 90 degree, and when 2 faces are perpendicular, then the feature must be 30. Depend upon how exact are you using your feature angles. Laxator is 3, and smooth surface normal is 1, and then smooth layer is 1, and smooth thickness is also 10. So stop layer growth only highly wrapped cells. Reduce layer growth where the ratio thickness to the medial distance is large. So the maximum thickness to media ratio is 0.3, and medial angle is 9, and buffer and extrude is no, and alters these are the basically for the layers, how many layers you want to add at the edge geometry. So that was the best if you are finding for a boundary layer or anything else. So that is the case with this one. So what about the mesh quality control? In the mesh quality controls, you can see the maximum orthogonality must be 65. Maximum orthogonality are low set to be 180 to be disabled. You don't want to 80, but the maximum is this. And the maximum boundary skewness is 20, maximum internal skewness is 4. At the boundary, the maximum skewness will be 20, and maximum internal skewness is a 4, and the concave is 80. Minimum volume is 0.01 10 to the power -5, minimum quality is -1, minimum area is -1, minimum phase 0.1, minimum determinant is 0.001, and minimum phase is 0.05. Minimum volume ratio is 0.011, minimum triangle twist is 1, and smooth is 4, and error reduction in this case is 0.10. Relax. Maximum orthogonality, if you want to change from 65 to 75 straight, relax up to the 75. So that is the best parameter in case of maximum orthogonality. Up till now, this is the overall mesh SnappyHexMesh, how we can just use and what does mean by these things which are present in this file. Now we just look at end surface feature extract and how we can just extract, and we will perform an experiment to check what is going to happen with our mesh in the SnappyHexMesh. Okay.
Okay, Wally. A lot of information to learn.
Just give me 1 second. And let me just first control it. Okay. Just let me this. Okay. Okay, now let me just do one simulation in front of you. Okay. So let me open right now is M surface VAM surface. Okay. I have added all the files that includes in 1.stl, 2.stl, 3.stl, 4.stl. These are the files which are present here in this case. Let me go for the column WQ. ls. Okay, now let me go to cd.dot. ls. Now we have to create a folder in a constant cd space. cnstm constant ls. So in this case, this is the dynamic mesh. Okay, we are also just going to perform some little dynamic. In this case, let me open this for VAM in dynamic mesh. You can see this is a motion solver solid by internal regions, axis of origin 0 0 and axis 0 long. One can see, and the omega of in radian per second is 158. Okay, now let me close this thing and add. We have to add our geometry here. First of all, we have to get through our geometry. What is our geometry right now? Let me check. Where tank files fix. Save two projects. No. Where is the geometry? Let me remember. In here or no here? No, this is not much. Let me open and check where I have put my files. No. Let me just download our first geometry. If you have any geometry, we can start it on your PC right now. Okay. Do you have any difficult geometry, Joseph? I think I have not any difficult geometry right now. Do you have any?
I it's a, I am in a noise place. You know, we continue a little, or it's depend of you.
Okay, now you can share your screen.
Ah, okay. I can share my screen, please.
Okay, now you can share. Okay, Open, do you have any geometry? Do you have any CAD geometry right now? Yourself?
I can hear you, okay, Walid.
I am saying that have you any CAD geometry?
Carla, okay. I guess no.
Open in ParaView. Open that geometry in ParaView. Open that geometry in ParaView.
Where is this? This specifically or the last one that we work?
No, any difficult geometry if you have. Let me see in my case whether I have or not. If I have, then I can start work on this. Just give me 1 second, okay?
Okay.
Okay, now I find it. I do not refer to folder, okay? Now let me save this at, let me create a folder here. Okay, now stop your sharing screen. Just 1 second, give me, let me just first save it. Stop, save. Okay, now let me share my screen. Can you see my screen?
Okay. No, yes.
Okay, now let me open a Rhino. In Rhino, I can just convert. The Rhino is a software in which I just convert this IGS file to .stl, okay? You can change in any software, anything you want to convert to. You can also do it online, okay?
Okay, Walid.
You can just, I'm just changing its format, not anything else, okay? File open. At desktop, I have C. Tank file, these are the tank desktop. At desktop, I have file of, yes, profile. Open. Okay, now can you see the propeller?
Yes.
This is the propeller. Okay. This is the also propeller. Now let us select this one. Let's not maximize this thing. Okay. Now I'm going to export it. Okay, now export. And then we just save a desktop. And that is will be an STL. Yes, there is STL. Okay. And properly. Okay, we are STL. Save. Then millimeters. Okay. ASCII. Okay. I think it's saved. Now let me save this thing. Yes. Cancel it. Cancel it. Yes. So okay. This is the IES. This one was the IES, and I want STL. Yes, this is the. Let me open my ParaView. I cannot open .IGS extension. The ParaView I have to open .stl. So I have converted this thing in .stl, and now we can open it in a ParaView. Okay. Extra. Can you see this? Okay.
Yes, I can see, Wally.
Okay. So this was the case we will perform in our simulation. Okay. This is the case geometry. Now we can mesh this in SnappyHexMesh. This is our one.stl. Okay. Let me just create a software here. What is this folder? And try let me manage the propeller. Enter. Enter this thing is okay. Now let me close, minimize this and open this thing. Right click there and open. Now like this. Five. Open it. Not right. Okay. Now I think I see everything is good. Like that. Now I have some saved this one. Okay. Now let me do this thing. What should I do now? I think I have now define a patch or anything else. Okay, I think matches. Okay. That is different. Okay, let us do it in a good way. What was the cylinder? Where is the cylinder in this one? Precisely the cylinder in this case. I have moved maximum things from here to there, but I didn't find where are my files. These are the by default files of tank. This is the mesh of the tank. And this is the simple car system monitor here. Okay, SCI hub. Now X Auspices master merge. Save to projects. No. Okay, let me just see here if I have any ready present here. Now let me give you tutorial for this just cd start ls and cd start string, yes, cd tan circle. And ls, let me go to the constant ctc here and constant ls. Okay, now you can see there are some features. One is the extend feature. The second polymorph. In tri-surface, we have geometries of our body. Okay, let me ls and cd. Yeah, tri-surface and ls. Now you can see I have different forms of meshes here. Okay, let me open these meshes for you. Minimize this and open paraview. Close this. We can do this simulation on later on. Okay. Now we can just simply performing our how SnappyHexMesh runs. Let me open. Now you can see case thing.form. Let me open and apply here. First. Okay, now can you see this thing how is working like this? Okay, this is
I can see
the
very.
can you see now?
Yes.
This was the mesh which I made from using the SnappyHexMesh. Okay, every blocks are equally distributed in this case. Okay, that's the third thing. Okay, this. Okay. Now let me just do this thing. How we just can create the first step in order to create a mesh is to do surface feature expressivity. LS space dot LS is right here. Simple home, not simple home. Right here. This one. The name of first of all, okay, block mesh. First, you have to remember block mesh. Block mesh is the background case in this case. Okay, first of all, you have to run block mesh here. Okay, block mesh is done. Then you have to run surface feature. Expect. You can see feature are also extracted. Let me run here SNA level T SNA level T SNAP X minus I. By this command, we can easily execute our SnappyHexMesh. Okay, W snappy hex. Okay, with the help of this command, we can just run our SnappyHexMesh and it will be our. Let me click over there. Oh, we have our. Just give me 1 second, Joseph, okay? Hello.
Hello, Khalid.
Sorry, Joseph. I just received a call, so that automatically
What
stopped.
problem, Khalid?
Okay. Let me share my screen. Okay, can you see my screen right now?
Yes, now I can see.
Now let me just click over here. This is the Snappy. I just put command in a right. Hex. Move this M, and this is Snappy HexMesh minus override. Okay, now you can see my simulation is okay. Now this is how it just create a mesh in in SnappyHexMesh. Okay, now after the end it will automatically come. So how we can just define? Let me open this thing for you in SnappyHexMesh. Click. Let me open this for you, so you can see. Okay, now I have defined our geometry like this. For example, file open, and then desktop. I have a file of a tank files. First of all, let me open outlet. Okay, so I have opened an outlet. Can you see outlet? This is my outlet in this case. Where is it? Expert. Yes, this is my outlet. Let me open one thing more for you. Wall,
Okay.
not wall right now. Let me inlet one. Let me open. Okay, and apply. Now, can you see my this thing? Where are they? I cannot see them by myself. Also, express. Why they are not moving? They must be moving in any direction here. Correction process, and open thing once again for you. File open and my document, tank files, and let one apply. Okay, can you just rotate it in any direction? Okay, this was the first inlet one. Open, outlet, apply, apply. X positive, access, Y positive. It will automatically move from here. I can do this solid color, and this thing out was solid color. But I can now still, I want to change in this directions. And to enable this, enable this. Okay, now can you see?
Yes, I can see, Khalid.
Okay, this was my inlet and this was my outlet. Let me enable one more thing for you. File open and click at inlet 2, then go for OK. And now I'm going to apply. Okay, now you can see. This is my inlet 1, this is my inlet 2, and this is my outlet. Now let me enable wall for you. File open, wall, and OK. Now let me apply this for you. Now you can see this is my wall. Okay. If I just disable my inlet from here, now you can see this is how my inlets work. And that is my exact outlet here at the end. You can see, let me disable for you. Okay, can you see this now? This is a solid color. Okay, good. Now you can see it. This is my outlet and this was my inlet, and there is another inlet which is you can see from this direction, that is in a blue. Okay, here is the blue. So we can define our full geometry like this in our case, and then we can perform simulation. And after then we have to perform three commands. For the what was the first one? The first one is a block mesh. The second one is a surface feature extract dict, and the third is a SnappyHexMesh. And after it, it will automatically create a mesh which you can see in this case. And right now, I think this is still running. This is the how SnappyHexMesh work in this case. Okay. If you have any question, you can ask me, but we can continue tomorrow. We will start work on SnappyHexMesh by giving an one example of propeller. Okay, today I think I have not exact geometries of propeller. Right now I am just finding the geometries of propeller. After finding the geometries of propeller, tomorrow we will start work on this propeller. Okay.
Okay, well, but tomorrow is Sunday. Maybe we
No, no,
start
no,
Monday.
no, no. We can start it on from Monday. By starting on propeller, we will also do three or more. The first one is a dynamic mesh. We will also literally work. I think dynamic meshing is not included in this course. Let me check, but still I can give you an overview of dynamic meshing. Okay.
If you share the files in STL format, I can appreciate for maybe continue practicing.
Okay, okay, I can share with you. Just give me 1 second. Let me first of all check the course content of this course. Courses grid. Let me check it. Introduction to OpenFOAM. Where is that course? Yeah, there is it. Introduction to OpenFOAM.
I was trying to enter, but the information is not available.
Sorry,
Okay, now it is appear.
I'm not understanding what are you saying. There is a lot of trouble
2
when
days ago, I entered the website and I couldn't find the information.
of this. Yes, there is no. First is the installation of OpenFOAM on Windows 10. Okay, we have done with on this and Ubuntu. Then installation of ParaView on Windows 10. Good, with we can done it. Mount Ubuntu simulation good. We have done it. Introduction of meshing strategies. Okay, first of all, first we have defined block mesh. Yes, good. What is a block mesh? We have defined block mesh. What is a SnappyHexMesh? We have defined SnappyHexMesh. How can import or export? Yes, we can do. I will tell you about all these things. Which format require data to? I can also tell them. How can you export mesh of? Okay, we can do it. Basic coding. You have a given overview of CDLS and CPC minus R. These are the basic. Yes, setup. We have done case setup and different method for post processing in OpenFOAM. Okay, I will give you the overview. But I think dynamic meshing is not included in this course. So what should I do? Okay, I will give you a little overview of dynamic meshing that is not in this course. I think that is present in advanced OpenFOAM, but still I can give you a overview so you can understand how basically how dynamic mesh work here in this case. Okay.
Okay, well, it thanks a lot.
Okay. If you still have any question, you can ask me. You can see that the mesh is still working now. Just wait for 1 or 2 minutes and see how it works. Then we can end our class, but still just wait for 1 or 2 minutes. Okay.
Okay, Walid, I don't have question for today.
Okay, just give me. I think that is the end of this SnappyHexMesh. They are just moving into their files, and it will be completed. And after that, we can check our this mesh. No, no, I have a mesh is already in saving here. Let me open that for you. SnappyHexMesh ParaView. I have to close this one for open and desktop tank files. Now this one and tank. Yes, tank.form. Okay, apply. You can see this is how it's work. After the meshing, it will look like this. Let it open first. Okay, this is how it works, and this is my inlet apply. Okay, this is my inlet and surface. You can see this is my inlet mesh. This
Okay, okay.
one mesh. Okay, this is my second one inlet. Okay, and this is my outlet. Okay, apply. Now I can see I have outlet and these are my walls. Okay. Now it will be open. You can see the mesh is hexa. There is no need to any doing. You can see.
Yes, Walid, I can see.
Can you see?
Yes, I can see.
Very good mesh, HexMesh, okay? Okay, that is the how. Let me just put one marker at one y direction, not in z direction. Okay, now let me apply for you in this direction and z poster, still okay. And close this thing in here and surface is like this, but this is a surface. I want to just change that from. This is the full face. Select. Oh, yes. Let me just give me 1 second. Let me close this thing. Slice one here. Read and also delete this thing from here. Let me open this thing for you. Thing.form. Okay. Apply. Okay. Set negative. Now let me just add a plane in y direction. With cursor. Okay. Apply. Now I have applied in this direction. Now let me close this. Now you can see this is the only plane. Okay. I have just cut it in 2 dimensions. So let me just you can see this is the mesh.
Yes.
Okay, you can see there is a wall with it is sticking like this, and it is sticking with a very good meshes at the wall. And also if you want to do anything internal or external, you can easily just copy or paste them. This is the exact mesh at the boundaries and the exact mesh at them. Can you see? You can feel this difference. Okay.
Okay, Wally.
So this is how exactly dynamic mesh, snappy hex mesh. From tomorrow, we can start practicing on this. How can we just practice? We can just take a one geometry and then we will try to do it in our different things. Okay.
It's okay, Wally.
Okay. No, up till now, if you have any questions, you can ask me.
No, I not have question.
Okay. Okay. Then we will start our class on Monday with propeller. Okay.
Monday, Wally.
Okay. Then take care. Bye bye.
Bye, Wally.
Thank you. Bye bye.